Hi, thank you for coming to the session where we're going to talk about supply, demand, and purpose. Purpose and species grouping, how to use information to identify drivers and impact on the wildlife trade towards Indonesia's songbirds. So with here talking about the supply chain and which part of the supply chain or which aspect of the supply chain can we identify to then figure out what the best solution is to tackle that. And this is what this presentation is going to be about, how to use existing information of supply, demand, and purposes to identify not only patterns, but also what species to pay attention to. So Indonesia's supply chain is like every other wildlife trade, commonly and often from the wild, taken and transported down, where it's also sold in the markets. And the markets is where consumers and sellers meet and interact. And then after transaction come, then the consumers will bring the pet home, or in this case, the songbird home. So then therefore, this will be the supply side of it, which is the supply chain and the market, and then the demand side of it. Interestingly, more than 200 Indonesian songbird species are actually found sold in markets in the supply chain, but only 55 have been recorded owned. So actually, what is going on? What is driving this additional supply? Why is there more than 150 birds in excess in supply in the supply chain? Is it driven by demand? Is it opportunistic catch and opportunistic sale? We don't know, but one for sure is we understand which birds are opportunistic caught, which ones are driven by demand, and also the understanding the patterns will help us find a better solution for conservation. So basically, just a bit more in demand in Indonesia, demand would then further be split down into particular purposes. There are 4 identified ones: competition, ornament, a master, and for breeding birds. So then we also could then understand even further what purpose would this supply also be catered to. Ideally, in economy, supply will then cater to demand, and then the demand would have particular purposes which are identified. But in Indonesia, like I said, there's over 150 species that are oversupplied. So then the supply might potentially create it opportunistically to drive demand where we don't know what it's used for. So therefore, over here will be likely demand-driven species, and over here will be likely opportunistic species. The thing is, it'll be great if we have this information to assess which species are demand-driven and which ones are opportunistic, but a lot of the informations are separate. We've got the supply, which is surveys and such available. We have demand information and purpose information, but neither of them are taught to have or been explained much of what the interactions are. So this is what we're going to try to tackle here in this presentation. And to do that, we use existing data and also our own data. So existing data, we use supply data, which focuses on Java, which we have. Java is the main hotspot for consumers. And we've got 4 market surveys already from the 6 provinces, and we've got supply chain information on birds that actually are aimed and destined for the province. For demand data, we have existing data that's published on household ownership, but on top of that, we want to know beyond household and also competitions and such. So we went in the field and got additional data to understand how many birds are owned by household and the ones that go competitions, how many birds or what birds are desired, because it's not just ownership that drives demand, but also what people desire driving demand. And also we talked to people, vendors, stall vendors, what birds are likely the best sellers. So we understand which are the most demand driving species. On top of that, we also ask what the purpose of birds are for, but the purpose would then be a further one. As we go back, as you can see, we've got supply demand, which is focusing on, but we also have a bit of information on the purpose in the end. But the first one, we're looking at supply demand, and then after that, on purpose. So the analysis that we've done is a bit complicated. Well, not complicated, but it might be a bit difficult to understand, but we're not focusing on that. Feel free to shoot me a message or ask detail if you want to know how we did this. This work is also being written up, so we hope to publish it soon and gives more clarity. Basically, we got a lot of sources of information with different units, and we first have to make sure that all units are uniform, ranging from 0 to 1. If they're not uniform, then they're different, you can't compare. So that's what we did. We normalized all data ranges from 0 to 1, where 1 has a lot of abundance or high abundance, and then 0 is no abundance. So it's like relative abundance. And then after we do 0 to 1, what we did is we compare it. We took the supply value and then we subtracted by the demand value, and then per supply value plus demand value. So the idea is if the supply is larger than demand, then the value will be positive. If the demand is larger than supply, then the value will be negative. And in this case, it ranged between -2 and 2. Where -2, the closer to -2 it is, the higher the demand and less supply, and vice versa. Closer to 2, that means it's oversupplied and less demand. A value of 0 means exact balance, which is like highly unlikely. If it's full on -2, that means there's no supply, and it's full on 2, that means there's no demand. So, and then we have so many different variables of supply and demand. Like we mentioned, we have market, and for demand, we have several variables as well. For each demand, we have ownership of competition, household, desired, and bestseller. So then we pair these. So we'd see whether market would cater to which one, ownership, desired, or bestsellers. And then the same with supply chain, which one does it cater to? So then each of this will likely, market would check how much it caters to. So each of this would be, this is one pair, market and household, market and competition, supply chain, household, supply chain and competition and such. And all of this would have a particular value associated with what we call the supply demand value. And so therefore there'll be 4 supply demand pairs for market and supply chain. And both of these, we look like the median average. And so then there'll be one value for market, the median average for market, and the median average for supply chain. It might get a bit complicated, but it's okay. But basically what it means is we have one value in the end to indicate whether the market supplies to the demand or not. And if it does, is it oversupplied or undersupplied? And whether the supply chain also oversupply or undersupply the demand. So, and then what happens is then we plotted these in a PCA, and we also plotted and further plotted the purpose in a correspondence analysis, which we'll get to. So in general, through that approach, we found existing information from our data and also existing data. There's 272 species of songbirds that were found in the trade. 246 of them were oversupplied, which is a huge percentage. It's around over 90%. 19 of those were undersupplied, only 19. 6 of them were, the market oversupplied them, but the supply chain undersupplied them, which means you didn't find the bird that was in demand in the supply chain, but a lot of them were in the market. And then the same, there's only one where you didn't find the bird in the market because it's undersupplied, but then you found a lot of the birds and the supply chain, and there is demand for this one, but it's oversupplied. So then we go into the plotting. So why we plotted this basically to find the pattern, to understand we have, with 272 species, we can't look at them one by one. So we plot them in a PCA plot. And through the PCA plot, we have 4, like I mentioned, there are birds that are oversupplied, undersupplied, market undersupplied, market oversupplied, and so forth. As we go back here, we have 1, 2, 3, 4 groups. And with the PCs shown 82% of variance, which is good enough. PC1, which is this one over here, it represents demand. A lot of the variables are highly contributing from demand. So the closer it is to PC1, the closer it is to be a species in high demand. And also the same one with PC2, the closer it is here, which is PC2, the closer it is as a species in high supply. So the patterns that we found is, first, distinctly purple is oversupplied. Species that are oversupplied are likely the ones that are market in seizure. And interestingly, you can see how there's a kind of an angle like here. And if it's like, this is an arrow here, so if it's in the same direction, it's correlated, but you can see how it's in a kind of an acute angle. So likely the ones that are supply aren't really the ones that are also in demand. So it is a very distinct pattern. So likely the ones that are in supply are oversupplied and opportunistic. Obviously with 246 species, that makes sense. Another pattern, obviously you see here the demands over there, and all of the species that are undersupplied really, really closely related to what is in demand. One species are really distinct over there, and you can see the direction is really correlated with variables of demand, which means this species particular is in high demand, and from all of them as its own in competition birds, own in household birds, its bestseller, it's desired. This is not supposed to be here, sorry. But all of the variables, it is a highly in demand and desired species that actually the distance is very distinct from other ones. And other patterns that we also found were this bird over here is the only bird that's undersupplied from the market and oversupplied in the supply chain, which means a lot of them were found throughout the supply chain, but hasn't reached much of the market. So we don't know whether it goes directly to demand or whether it's just being opportunistically caught in high volumes to the point that, you know, it's oversupplied in the supply chain. And you've got patterns over here of species that also quite, the directions are quite high in demand. You've got 2 species here, so then you can identify those patterns. In general, we found that market and supply chain supplies are not likely driven by demand, a huge proportion of it. And that obviously with undersupplied caters more to the demand and not likely caters to what is being in supply. Then we further took it again, we did a different kind of plotting called correspondence analysis to see, because it's more categorical for purpose, which purpose is catering to supply. So we can see that the supply chain again with the market, so catering lots of these species which are oversupplied, but then you have undersupplied species that are used for purposes such as competition breeding, and over here is master birds. And down here, as you can see, the dimension one is actually, so sorry, species undersupplied are likely driven by demand identified with a particular purpose. But interestingly, over here, you can see that this is the first dimension, looking at supply chain and breed, which is the two main contributors, first dimension, and the closer they are to this first dimension, this line, this first dimension one means it's likely to be correlated. So this one is likely to be also found in the supply chain and also found for breeding. So basically, we can see that, again, it just further confirms that supply is, that oversupply species, the market and supply chain are more filled with oversupply species, and the undersupplied ones are the ones that are in high demand are likely not in the supply chain. So we think like, okay, if it's not in the supply chain, what's going on? Maybe it's not in the supply, we're fine, these are safe. Maybe they're from different sources, maybe they're sourced from breeding because a lot of these are bred as well, but apparently not. They are much higher. What it indicates is actually that the birds are much higher in demand than they are in supply compared to others, but you still have to look at the context of what's going on. And these are the birds that are undersupplied, but you can see how it's being smuggled 1,200, 1,500, 468. It's not from Indonesia, it's from Malaysia. So they are in such undersupply, and they seem to like cater to, a lot of them are really high in demand. As you can see, they're located with demand, but the supply isn't providing it. So it's coming from elsewhere. So things like this is what we need to keep alert. When we see undersupplied species, where are they coming from? How are they being supplied? Because if there's a species in demand, obviously they're going to be in supply. If the species in supply is, obviously there's going to be demand. So we need to match those. Again, this talk about is important about matching demand and supply. So then we know which ones to look for and what pattern. There must be patterns missing, how to identify them and how to know which one to look closer to. So almost wrapping up, this approach shows how to use existing supply and demand to analyze patterns and identify patterns. High demand are usually undersupplied. We need to know where it comes from. High supply is, we need to ask where the birds go. The approach should be treated as an initial approach if you want to use further or design for conservation initiatives. But you have to make sure that it's a constant monitoring effort because things change, patterns change, and market change. So constantly monitoring and updating of this information is crucial. Thank you very much. I'm happy to have questions and discussions after.